Hi guys. So for this week, we're going to be solving for sides and angles of right triangles using trig and inverse trig, but we're going to be doing it with word problems. So there's some new terms we need to know in order to draw our triangles out and be able to solve these problems. The first one is angle of elevation. So elevation, like on an elevator, you're going up, and the other one's angle of depression, which means you'd be going down. So we have basically an observer. So it could be you, it could be another person, it could be a plane, a boat, some sort of observer. And then there's an object. So if the observer is looking up at the object, we're going to have an angle of elevation. Right. So you have wherever the observer is, we're going to have a horizontal line. And then if they're looking up towards an object, we're going to call that increasing the angle there, the angle of elevation. All right, so here is a problem, an example problem using an angle of elevation. So Brian is flying a kite. So we have Brian here. All right. Okay, and he's got a kite. Okay, so he's flying a kite. The string on that kite is 65 meters long. Okay, so the string length here is 65 meters. If the angle of elevation, so here's where the base of the kite string is. So that's going to be where our horizontal is. Okay, so it's telling us our angle of elevation is 70 degrees. Okay. It's also telling us that Brian is holding the kite 1.2 meters off the ground. So this distance here is 1.2 meters. Okay, this was 65 meters. And we want to know how far above the ground. We want to know this distance here. Okay, well, we know this small piece right here is 1.2. That's how high off the ground he's holding it. And what we need to find then is the next piece here. So we can add those two together and find the actual height of the kite. Well, we notice we have a right triangle. We're solving for a side of the right triangle, so we're going to use trig. All right, we have SOHCAHTOA as our mnemonic to pick which one we want to use. So SOHCAHTOA. Okay. Hypotenuse is across from the right angle, so that 65 is our hypotenuse. The angle we're interested in is the 70 degrees, and the x is across from it, so that's going to be opposite. So we have opposite and hypotenuse. So we're going to be using sine here. So the sine of our angle, so the sine of 70, is going to be equal to our opposite side x over our hypotenuse, which is 65. Okay, and then we just need to solve for x. So multiply 65 on both sides. Okay, those cancel. And then 65 times sine of 70. So make sure you're in degrees. And then we're going to do 65 times the sine of 70. Hit equals, and that's 61.1 meters. 61.1 meters. So this is going to be 61.1 meters. We don't want just the height of the triangle. We want the entire height off the ground that the kite is. So we need to do 61.1 plus 1.2 meters. And that's going to give us 62.3 meters. The kite is going to be 62.3 meters off the ground. And we used our angle of elevation here. That's the angle going up. Okay. Our next term was angle of depression. So angle of elevation is the angle going up. Angle of depression is the angle going down. So when you have a horizontal line, okay, based on where the observer is, whether it's a person, a plane, or something else, and you're looking down, that's going to be your angle of depression. So here we're looking down, so that means this angle here is our angle of depression. All right, so an example problem for angle of depression, we have an airplane, which is a common problem. Okay, so there's an airplane. It's got some wings. That's good enough for an airplane, I think. It has an altitude, which means height, of 1,200 meters. So it is, here's the ground. Let me try to draw the ground a little better. Here's the ground. It is 1,200 meters off the ground. Okay. And the angle of depression to a rock on the ground is 28 degrees. So there's a rock on the ground. Okay, so we need to draw an angle of depression. So we need the horizontal for the plane. So we can draw the horizontal for the plane in. Okay. And then we're looking down to the rock. So our angle of depression is 28 degrees. So if we look back at the previous slide, again, our angle of depression is the angle going down. So in this case, this would be the plane. Okay, the plane's driving along or flying along this horizontal. And when you look down, that's when we have our angle of depression. All right. There's two ways we can approach this problem now. If we want to find the distance, the plane to the rock, that's this piece here. We can use the alternate interior angle theorem, and that means this angle here is 28 degrees. Okay. And then again, we have SOHCAHTOA. We're solving for a side, so we're using the regular trig function. X is our hypotenuse. This is the angle in question. 1,200 here is across, right? So that's opposite. So we're going to use opposite hypotenuse. That's going to be sine. So the sine of 28 is going to equal the opposite 1,200 divided by the hypotenuse. Okay. We could have also done this a different way. Okay. You could have drawn this line in here. Okay. And then if this is 1,200, this over here is also 1,200. And then we could have used this triangle right here. And again, you would have had a hypotenuse, and then this would have been opposite, so you still would have gotten the same equation. So you could use this green triangle here or this red one. It's still going to give you the same equation. Okay, so to solve for x, you got to get x by itself, so we need to multiply both sides by x. And then you end up with x times sine 28 equals 1,200. And then to get x by itself, we need to divide both sides by the sine of 28. So that cancels, and we're left with x equals 1,200 divided by the sine of 28. So x is going to be, what was it? 1,200 divided by the sine of 28. So 1,200 divided by the sine of 28. Okay, we hit enter. 2,556. I think it's meters, right? Yep. 2,556 meters. That's how far the plane is from the ground. Okay. All right, and that's it for the first lesson for notes. I will do a separate video though going over example problems, and then we will have also the walkthrough. Okay. I just don't want to make one video that's too long.